3, Powers and Exponents. Okay, 1.3, Powers and Exponents. Once again, I want to remind you that you can go on to RenWeb, and the links for the YouTube videos and those types of things are there for you to get. And if you need to find something, that there's some resources there under your name, under math class, math 7th hour. Okay, so you can get to the YouTube link there. You can also get to the notes that we do every day there as well on the resource tab. Yes, Trinity.
It has the wrong date on there.
Has the wrong date where? I wouldn't worry about that. All right. Everybody write this down. 3 to the 4th power. Write it big. 3 to the 4th power. Okay, I want you to hold it up. 3 to the 4th power. I want you to hold it up. When you're done talking, I'll continue. Okay. 3 to the 4th power is what most of you wrote. Some of you wrote it in words, but I didn't want it in word form. I wanted it just like that, 3 to the 4th power. Now, the 4 is the exponent. Okay? The 3 is the base. Okay? The 4 is the exponent. The 3 is the base. The exponent tells us how many times we're going to multiply the base by itself. So, this expression then is 3 times 3 times 3 times 3. Now, this would be what they call expanded form. If I took this and said 3 to the power of 4, okay, that would be word form. Okay, if I took it and actually multiplied it out, 3 times 3 being 9, times 3 times 3, 9 times 3 being 27, times 3, 27 times 3 be 81. This would be evaluate. Okay, when we evaluate something, we substitute and simplify. Okay, when you evaluate something, you substitute in an expression and you simplify. Okay, what we substituted in was this. 3 to the 4th power, and then there we substituted in 3 times 3 times 3 times 3. Okay, that's the substitution part. Then actually multiplying those things out got us to 81. Okay? So, that's how we write an expression from exponential form to simplifying it. That's how we evaluate it. Trinity.
When it says like an even number, can you put like 3 times 3 and then 3 times 3 and then put 9 times 9?
Yeah, same thing. All right, now remember, 3 to the 4th power is not a new way to say 3 times 4. Okay, that is not correct. Okay, so don't say it's 12, in other words. Okay, the exponent represents the number of times that I'm going to take the base and multiply it by itself. Okay, that's what the exponent represents. So let's look at another example. Five to the 3rd power. I want you to evaluate I want you to evaluate 5 to the 3rd power. So I just told you what evaluate is. So it's up to you to look at your notes, see what evaluate was, and see if you can come up with the answer that I'm looking for. We're looking at 5 to the 3rd power. You're not done yet. No. Nope. Look what you have on paper and then see if you is that what you did in your head. What you have on paper is right for the second step, but the answer is not correct. Remember, this is not a new way to write 5 times 2 or 5 plus 5. It is not a new way to write that. So if you're coming up with something like 10 or you're coming up with 15, you're wrong. And I need to see your work. Did you not learn that from our last little discussion? There's no work shown there. That is not correct. Nope. Yes. 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 Nope. Yes. 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 Nope. All right, let's look at it. This means 5 times 5 times 5. That's the substitution. Okay? Now we must take this and simplify it. Okay? Some of you did one of two things wrong. Here, some of you went, if you got it wrong, you went 5 plus 5, and you got 10. No, 5 times 5 is not 10. 5 times 5 is 25. Now, several of you from this point, you either got 30 or you got 50. I know how you got 30, not real sure how you got 50. Okay, because 5 times 25 is not 25 times 2. Okay, and that's what 25 times 2 is 50. 25 plus 5 would be 30. Okay, so I multiply 25 times 5 which is 125. And that is your answer. Okay, 125 would be your answer. All right, now, 4 to the 5th power. And they want us to evaluate 4 to the 5th power. Okay, 4 to the 5th power means 4 times 4 times 4 times 4 times 4. So I took 4 and multiplied it by itself 5 times. Okay, 4 times 4 is 16. Times 4 times 4 times 4. 16 times 4, 64. Times 4 times 4. This is how you show your work, Jesse. 64 times 4 is 16. Carry my 1, be 116 times 4. Oh, my bad. 256. My bad. 256. Yeah. 256 times 4, okay, it's going to be 4 to 1,024. And that is your answer. So that is what 4 to the 5th power evaluated is. Okay, it's 1,024. Now, this is called exponential form. Okay? It is also called the product of powers. Okay? This book will call it the product of powers. Eventually your book will say write it in exponential form. Sometimes they're meaning one of two things, and so you'll just have to look at it when you get to that point and see. Okay, because exponential form can have a different meaning sometimes. Okay. All right, now let's look at taking this and writing it as a product of powers. It doesn't tell us to evaluate it. It says write it as a product of powers. Okay? So they want us to write this in what we just called exponential form. In other words, they want us to go from here back to the first part. Okay? So 3 times 3 times 3 times 3 times 3, Tristan, would be what? 3 to the 5th power. So that would be your answer, 3 to the 5th power. That is written as a product of powers. Okay? Another one that they will give you looks like this. Now they're going to use some variables. So we have t times t times t times t. Okay? And that would be what? How would I write that as a product of powers or in exponential form? Quade? Yes. T to the 4th power. Okay? Obviously, the 4 goes behind the t at the top. Okay, there's a difference. There's a difference between this and that. These are not the same. T to the fourth and 4t are not the same. Okay? Everybody look at number 33 on page 16. Number 33 on page 16. 33 says a checkered board has 8 rows of 8 squares. Write the number of squares on a checkerboard as a power and then use mental math to evaluate. So if there's 8 rows of 8, how can I express that as a product of powers? Trinity?
8. I don't know what it's called, but a big 8 and then a baby 8.
A big 8 and a baby 8? No. The base would be the 8 and the little 8 would be an exponent. But that's not right. That would be what you've described would be 8 times 8 times 8 times 8 times 8, 8 times. Okay? And that's not what they're wanting. They said 8 rows. So I got 1 row, 2 rows, 3 rows, 4 rows, 5 rows, 6 rows, 7 rows, 8 rows of 8 squares. Okay? So how would I write that, Jesse? Yes, 8 to the power of 2, or 8 to the second power, or 8 squared. Okay, that's the 3 ways that I can say that. 8 to the power of 2, 8 to the second power, and 8 squared. That's the first answer. The second answer is they want you to evaluate that expression. So we've got to evaluate that. We said evaluate is substitution and simplifying, but they said use mental math. So, Gabby, what would it be? Okay, what's your question?
Why is it 8 to the power of 2 if there's like 8 rows?
Well, there's 8 rows of 8. So what would you do to find out how many squares there are? You would take 8 times 8, right? So that would be how many 8s? 2 of them. And so that's why it's 8 to the second power. What is 8 times 8, Quade? 64. So your two answers the two answers would be 8 squared and 64 squares. If you don't put the squares with it, it's going to be wrong. Because it is a word problem, we must be descriptive in our answers. Okay, what they're asking for, you must answer. Sort of like when I've been telling you to show your work and you didn't show your work. Okay, unless it says use mental math, you need to show your work. Even when it says to show mental math, you must write the original problem unless it is a word problem. Okay? Now, look at the next one. I want to look at number 36. 36 says m to the third power when m equals 10. M to the third power when m equals 10. So, that means I have this. It is not a new way to write 10 times 3. 10 to the third power, I simply took this 10 and plugged it in for the m, and that gives me 10 to the third power, which in turn means 10 times 10 times 10. And no, 10 times 10 times 10 is not 30. Okay? It is not 300. Okay? Tayshawn, what do you think? What? 10,000? No. Not 10,000. Kennedy. 1,000. The answer is 1,000. Because 10 times 10 is 100. Times 10, which is 1,000. So that's what it's equal to. Now, let's say I had 6 to the first power. 6 to the first power is simply 6. Let's say I had 1 to the 6th power. 1 to the 6th power is 1 times 1 times 1 times 1 times 1 times 1. And that's 1. It's not a new way to add 1 6 times. It's not a new way to say 1 times 6. It is 1 times 1 times 1 times 1 times 1, which is 1. Okay? Now, anything raised to the 0 power, 12 to the 0 power, is 1. 15 to the 0 power is 1. 100,000 raised to the 0 power is 1. Anything raised to the 0 power is always 1. Okay, Trinity?
What makes it 1?
What makes it 1? Because if you think of it in these terms, what is 10 to the first power equal to?
10.
Okay. What is 10 to the second power equal to?
100.
Okay. So if 10 to the first is 10 and 10 to the second is 100, then 10 to the 0 can't be 0. So the only thing left that it could be is 1. So every single number, like for example, 12 to the 0 power would be 1. 12 to the first power would be 12. 12 to the second power would be 144. Because you can't take a number and multiply it by itself 0 times. And so therefore it is 1. It is not 0 because you're not multiplying the number times 0. Okay? You're multiplying it, you're raising it to the exponent of 0. Okay, so every single problem will be like that if it's raised to the 0 power. Gabby?
Can you scroll down really quickly?
Go down. Yep.
Can I show you on the board?
Yep. I need to go further.
Wait, is that 6 to... Oh, no, it's 1 to 6.
Yeah, 1 to the 6th power. So I used 1. 1 times 1 times 1 times 1 times 1 times 1 times 1. 6 ones. But when you multiply 1 times 1, it's 1. 1 times 1 is 1. 1 times 1 is 1. That's why it's 1.
Because I thought it was 6 to the first power. So
No, 6 to the first power is 6.
Okay.
Yeah. Any other questions? Okay. Your homework. Your homework is 1.3. (16 through 44). Now, everybody look at number 37. 37 gives us the number 16, and they say write the number as a power. Okay? They don't want you to write 16 as a power. They want you to give them something to a power that equals 16. Okay? So what number times itself equals 16? Jesse? No, 8 times 8 is 64. See, what you're doing, and this is a common mistake, is you just cut it in half. Don't cut. Raising something to an exponent is not cutting it in half. Taking the square root of something is not cutting it in half. What do you think, Jesse? No. 4 to the power of 2. 4 to the power of 2 is 16, and there's another one. Okay? The other one, it's going to be harder to see, is 2 to the 4th power. 2 to the 4th power is 2 times 2 times 2 times 2, and if you multiply it together, you get 16. So it can be either one of those. I'll accept either answer. Doesn't have to have both of them. Now, that is the only one. Well, not the only one. Okay? That's slime or goo. All right? So your homework is 1.3, 16 through 44. That is due tomorrow. Once again, let me stress to you, you must write the original problem unless it's a word problem. Okay? Word problems are 2 or 3 lines of sentences. Okay? You must show all of your work underneath the problem, not all over your page. Okay? You will notice that I didn't do, right up here, I didn't do this, different parts of my page. Okay? How hard would that be for you to take notes if I decided to put this here and then put some more work over here, more work over here, more work over here, then go back up here and finish it up? How hard would you be able to keep notes, take notes? It'd be very tough. So work downward, put your answer down below it, and circle it. Okay? It is due tomorrow, Quade. Make sure you're in the homework section, not the notes section. I want your answers underneath the problem. Your answers need to be underneath the problem. You need to show all your work, and you need to read the directions carefully. Okay? All right, you may go.